And the place was just an incredible place to work. So when my job ended there, my 2 years ended in 2008. I wanted to remain involved. So I signed up for JPL and NASA's Solar System Ambassador Program to be a community outreach volunteer, and I've been doing that now for the past 15 years, and I'm really enjoying it. This is really fun for me. This is about as fun as any volunteer job I've ever had. Now, as I mentioned, I am a volunteer for JPL and NASA. Right now, there is a government shutdown, so the volunteer coordinator at JPL did ask us to do one thing. Now, um, I've got a volunteer badge, a NASA JPL volunteer badge, and because of the government shutdown, I'm going to follow guidance from NASA, and I'm going to remove the badge. So I'm going to remove my official NASA volunteer badge because of the government shutdown, and that will be the only impact on this presentation from the shutdown. So, so that being said, the title of this presentation is basically NASA's search for life on Europa, Enceladus, and Titan. And I just think this is just a really exciting topic, and I'm pretty excited to be able to share this with you. Now, in the search for alien life in the solar system, Mars has always been the focus of public attention, right? You hear a lot about Mars, especially with recent discoveries of the strongest evidence yet that life may have existed there. However, to me, Jupiter's moon Europa and Saturn's moons Enceladus and Titan are even more interesting than Mars. They're just amazing places, like out of science fiction instead of science, but they're just amazing places. Now, my friend Neil Farber briefly discussed these three moons in his recent presentation on general astrobiology in July. And this presentation is focused on these amazing places and will expand on what Neil shared. Um, Now, as I mentioned, to me, it's just fun and exciting to share what NASA has learned about these worlds. Some of NASA's discoveries feel more like science fiction than reality. So thank you for the invitation. Thank you for the invitation today. I mean, to me, this feels more like sharing a slideshow, and but sharing slides of cool things NASA has found instead of sharing slides of my vacation. And so I've been really looking forward to this. So this is a quote from Carl Sagan. He said, "The exploration of other worlds may one day have profound implications for biology because all life on Earth is built on a common biochemical master plan. The discovery of a single extraterrestrial organism, even something as humble as a bacterium, would revolutionize our understanding of living things." And again, that's Carl Sagan. That's the guy who's famous for talking about billions and billions of stars. And that's, I think, just a really succinct quote for why exploring these places and looking for life on outside the Earth uh, is such an exciting and important thing to do. Now, the general guideline in the astrobiology community is the search for alien life focuses on water. Water is a fundamental building block of all terrestrial life as we know it. So I'm going to present a rhetorical true or false question that geysers like Old Faithful and Yellowstone have been found only on Earth. Now, is that true or false? And of course, everyone knows from watching the news and from listening to Neil's presentation 3 months ago that that is false. And that's because we know that there are geysers on Saturn's moons Enceladus. And Neil mentioned these geysers, but he didn't have the time to show pictures of them. So I'm showing pictures of these geysers. And, and this picture on the lower left here, it just blew me away when I first saw it, and it still blows me away. Now, you see the diameter of Saturn's moon Enceladus, right? Enceladus is 400 miles in diameter. That means from the top of Enceladus, the North Pole of Enceladus, to the South Pole of Enceladus, that's 400 miles. That's the distance from here to Los Angeles, right? Now, Enceladus has low surface gravity. It's not a very big moon, right? So when water spews out, it really spews out. So you look at this false cover image of the geyser of the water spewing out of this moon. It's like twice the diameter of the moon. This is like an 800-mile long plume of water. It's like going from here, past Los Angeles, excuse me, past Los Angeles, past San Francisco. That plume is just insane, right? And that's liquid water. That's liquid water coming out of this moon of Saturn. Um, and uh, 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 is everyone still with me? I'm just trying to make sure I'm still um,
You're good, Richard.
on.
You're good,
Okay,
Rich.
okay.
Yes.
Yeah, so that picture just to me is just amazing that the geysers are that high and the water is spewing out to the extent that it is. On the right is another picture showing again more geysers shooting out of the south pole of this moon of Saturn. And again, another picture of showing the geysers and just how amazing this is. This is liquid water spewing out of this little moon of Saturn. Um, Now, here's a picture of Enceladus. You can actually see with a telescope. I've actually seen this moon with a telescope. And it's one of the smaller moons, right? It's not a gigantic moon. You see the size, the relative size of Enceladus with respect to the other moons. This picture also shows Titan, which we'll discuss later. Titan, of course, has an atmosphere. I mean, Titan is one of the biggest moons in the solar system. It's the only moon in the solar system with an atmosphere. And we'll talk about Saturn a bit more later. But at the moment, what we're focusing on is the smaller moon on the left called Enceladus. Now, the pictures of Enceladus and its geysers were taken by JPL spacecraft, whose mission ended. Now, the water in Enceladus's geysers is coming from an ocean beneath the moon's surface. What's exciting about this ocean, compared to oceans on other moons that we know of, is it's relatively close to the surface. And we know that an energy or heat source has to be produced in the geysers. We also know that organic compounds, including phosphates, which are a critical building block of DNA, have been detected in the geysers. So you've got liquid water, you've got a heat source, you've got critical building blocks of DNA, you've got organic compounds, all on this little moon of Saturn. And so it makes you wonder, could there be life? Could there be life on this little moon of Saturn where nobody expected it? So at this point, I'm going to stop, and I am going to stop sharing. And I'm going to share a video if I can figure out how to do this. So let me open it. Okay, it's uploaded.
Recently, Cassini has found that a tiny moon that orbits around Saturn has jets and plumes of water coming out of it. These particles go out and they form the E-ring. And in flying through the E-ring, one of the instruments on Cassini, the Cosmic Dust Analyzer, can take those particles and get a composition. And as part of that, they see salt.
This is salt, and this is what we found in the ice particles we detected in Saturn's E-ring. And what we think is that the salt comes from an ocean below the surface of the moon Enceladus. The sodium is a tracer for subsurface ocean. That's the material of the ice particles, kind of water, like on Earth.
And that salty ocean tells us something about what that might be going on inside of Enceladus to create the jets and plumes that you need. Water, liquid water, in contact with the rocky core to get out the sodium. So think of maybe the plumes of maybe sort of the breath of Enceladus, coming out and telling us something about its interior.
So what we can say is we have a reservoir of liquid water, and liquid water is one of the preconditions for forming life.
I was surprised and also very excited to find out that, we're getting closer and closer to the conclusion that you have liquid water and possibly a liquid ocean on a moon that's so tiny and in a place where we didn't expect to find conditions where you might find life. This tiny moon, is 300 miles across, going to have liquid water and the conditions, the precursors for life.
I apologize. That was probably kind of choppy, but I hope that that got the main points across there. So let me bring up my PowerPoint presentation again.
We could hear most of it, Rich. It was a bit choppy. But we could I at least I could hear most of it.
Okay, that's good to know. Okay, I should be sharing my screen again. And so going forward, the next mission that is planned is called the Enceladus Orbitlander. And the plan is for a joint mission in that it would both orbit Enceladus and eventually land on Enceladus after flying through the geysers and doing an orbit exploration for about a year and a half before landing. It's a proposed mission. It's not yet funded. It would arrive at Saturn in the 2040s. So that's what I have to share tonight on Enceladus. And before moving on to the next topic, I'll open it up for questions here. So I'll stop
Hi, this
sharing
is
here.
Greg. I got a question. So water's coming out of the moon. Does water ever go back into this ocean?
Um, that's a good question. But I think overall it just needs to be characterized better, and we need to basically find out more about it and about what's going on with it. But um, I, the moon is so small that I would expect it to be more of an outward movement versus coming back. What I do think is pretty cool about that video is when I was in school, and this is a bit of an aside, when I was in school and they talked about Saturn's rings, they said, we don't know where the particles in Saturn's rings came from. That video just now, that scientist kind of did it almost as an aside. She said, oh, there's geysers from Enceladus and they go and form Saturn's E-ring. And she kind of like downplayed it like it wasn't a big deal. But considering that when I was in school, they said, we don't know where the rings of Saturn came from. She just explained where at least one of the rings came from. They're coming from this moon shooting geysers of water into orbit around Saturn. And so I thought that was kind of cool about that video. And the scientists in that video completely downplayed it.
Yeah, it was. It was good because I mean now we can say some of them. We can say, hey, that ring came from Enceladus, a moon. So that sounds good. I was interested in. Seemed like you'd run out of water eventually. Thanks, Rich.
I hope not.
So that's a lot of water to make a ring.
Yeah, it is.
Richard, we have a question in the chat room as well from Zach Walker. You said earlier that Enceladus has atmosphere. Would you happen to know its composition?
Oh no, Enceladus doesn't have atmosphere. Titan has atmosphere. Enceladus is too small. Titan is the one moon in the solar system that has an atmosphere, and it's really, really thick. Yeah, no problem. Anything else? Okay, we'll move on to the next topic here. So I'll share my screen again. And okay, and these, is my screen showing?
Yes.
Yes.
Okay,
Yes.
these are
Yes.
just fun true or false questions. Okay, and so what I've written here is true or false. Earth is the only known planet or moon with liquid seas or oceans on its surface.
False.
False, yeah. Question 2. Is Earth the only known planet or moon with significant amounts of, in quotation marks, fossil fuels, oil, coal, or natural gas? Right? And we know that's false too, right? And then question number 3. Is there a planet or moon in the solar system with enough propane to grill 2 trillion hamburgers? That's trillion with a T. And then the last question is there a planet or moon in the solar system which resembles a frozen version of Earth several billion years ago as life was evolving? And so I like putting those questions out there because it just like shows how incredible these places are, in that there is a moon in our solar system with liquid seas on its surface, but they are not seas of water. They are seas of natural gas. They are seas of liquid methane. It's so cold on this place that the methane liquefies. This place also has hundreds of times more hydrocarbons than all the known oil and natural gas reserves on Earth. That's a direct quote from NASA. This moon has hundreds of times more liquid fuel than all the known oil and natural gas reserves on Earth. It actually rains methane on this moon. Think about it. You've got rain, but instead of water coming down, you've got methane, you've got liquefied natural gas raining on you. That's how crazy this is. And did any of you guys ever watch King of the Hill? King of the Hill with Hank Hill selling propane and propane accessories? Hank Hill would love this place because this place has enough propane to grill 2 trillion hamburgers. Somebody actually calculated that. That's how much propane this place has. It also resembles a frozen version of Earth several billion years ago, and scientists believe that this place may support early forms of life, or because it is similar to early Earth, at least help us understand how life evolved on Earth. So where is this place? I think you guys know, it's Titan. It's the big moon of Saturn. It's Titan. And so, quoting again from Carl Sagan, if we want to study the origins of life, if we want to know where we came from, we need a real world whose atmosphere still retains some of those hydrogen-rich gases like early Earth, a world in other respects like the Earth, a world in which the organic building blocks of life are being massively generated in our own time, a world we can go to seek our own beginnings. There is only one such world in the solar system. That world is Titan, the big moon of Saturn. And in that paragraph right there, if you read carefully and absorb what Carl Sagan said, that just blows my mind. I look at that paragraph and I'm just, my mind is just blown by how unique this place is. And then to expand on this, here's a slide from NASA. Photochemistry in the upper atmosphere of Titan produces complex carbon molecules. So you've got this rich organic material covering the surface of this place. So there's potential for the organic compounds to have mixed with liquid water for extended periods of time at the surface, which makes Titan a singular destination for understanding the chemical processes on Earth that supported the development of life. And then if you look at the complex carbon-bearing molecules and the most complex ones on Saturn, Jupiter, Venus, Mars, Earth, and Titan, the only place that comes close to what we have on Earth is Titan. And then it also has the key ingredients necessary for life. It's got energy in the form of sunlight, photochemistry. It's got complex organic material in abundance. And there's 2 liquids available. There's water available beneath the surface in an interior ocean. There's also methane at the surface, and liquid methane could support development of alternate biological systems. Again, it rains methane. It rains on Titan. It's shown in the picture here. There's clouds, there's rain, but it rains methane instead of water, which I can't get my head around. No matter how often I've heard about it, I can't get my head around it raining methane on this moon. So on Titan, we can study prebiotic chemistry in the full context of a planetary environment with Earth-like surface processes. It's an ocean world. There's a subsurface ocean with liquid water underneath the surface, and Titan is uniquely similar to Earth in its diversity of surface compositions and geological processes. It has a subsurface ocean of water and a nitrogen atmosphere. And what else? Who else has a nitrogen atmosphere? Earth. So So here's a picture of the lake of liquid methane. On the right is Lake Superior, which is the largest of the freshwater Great Lakes. On the left is a picture of a lake of methane on Titan, and that lake is bigger than Lake Superior. And to go even further, here's a comparison between Titan and Earth. So Titan and Earth both have lakes and seas. Titan and Earth both have impact craters. Titan even has sand dunes. Titan even has sand dunes like the Earth. So, okay, so here is what I consider a highlight that I'd like to share, in that Mars, as I mentioned, has gotten all the attention because we know multiple rovers have landed on Mars. But what a lot of people haven't heard about is about 20 years ago, the European Space Agency piggybacked a probe called Huygens onto Cassini, and that probe was dropped onto Titan. And so this is, if you look it up, it's the most distant landing ever successfully pulled off in the history of humanity, right? Because this is the only landing that's ever been successfully done in the outer solar system. And this video is actually posted online. You can actually go to YouTube and watch this, but I want to share this with you guys because I've watched this many times, but every time I watch it, my mind is blown because this is a landing on a place billions of miles away, and we're on the surface, and this is a place where it has potential to be the first place where we discovered life outside the Earth. So I'm going to share this video with you guys. Okay, is my screen showing?
Yes.
Okay, so what we're going to see is a video, or it's actually, I think, actually strung together pictures, but it's essentially a video taken from the Huygens probe, which is dropped from Cassini through Titan's atmosphere onto the surface of Titan in January 2005. And this, to me, is just an insanely incredible video.
January 14th, 2005 begins with the Earth passing directly in between the Sun and Saturn.
And this starting image just blows me away. Did any of you guys see the transit of Venus in 2012, like the once in a lifetime Venus transit? I remember projecting it onto the sidewalk, and you could actually see Venus, the shadow of Venus against the sun, and Venus is about the same size as the Earth, and it was just a little dot. So it really, when I was watching that, I was thinking, wow, that's how small the Earth is compared to the sun. But that was the transit of Venus in 2012, and this is a transit of the Earth as seen from Saturn.
An opposition so perfect that it occurs maybe twice per millennium. Meanwhile, the Huygens probe, quietly entering the Saturnian system, is about to end its 7-year journey. As Huygens approaches, the inner planets cluster around the distant sun. Saturn appears almost as large as Orion. A few moons are visible as white dots aligned with Saturn's rings, while Titan, its largest moon, is already well resolved. Huygens is destined for Titan, a mysterious world larger than the planet Mercury and shrouded by a thick brownish-orange atmosphere. The details of its surface have never been seen. Huygens' speed increases to near 6 kilometers per second, and Titan's disk quickly obscures our view of Saturn and its more intimate moons. As the probe enters Titan's atmosphere...
So I'm going to stop it here to make another comment. And this must have been really, really exciting for the mission scientists because they've known for hundreds of years that Titan has an atmosphere, and no one's ever been able to take a look beneath the atmosphere. So humanity is going to get a look underneath the atmosphere for the first time ever. This must have been incredibly exciting. My one criticism of this video is I think the music is too tame. It's really like elevator music, and it kind of puts you to sleep. I think they should have, played like Kenny Loggins' The Danger Zone or something, or some like rock and roll music, really jazzy music to this video, because it's an amazing video, but the music kind of puts you to sleep. So, but it's pretty cool because we're going to see, as we play this video, what's underneath the atmosphere that nobody has ever seen before.
The heat shield reduces the speed some 15-fold within a few minutes. The main parachute reduces the speed further. 15 minutes later, the smaller stabilizer chute allows a faster descent at first, but slows as Huygens enters the lower, denser part of Titan's atmosphere. Huygens is approaching a dark valley between brighter hilly regions. Beyond the hills to the left, two dark parallel lines appear, which are later discovered to be part of a vast system of dunes which surrounds the moon. At 21 kilometers altitude, the probe moves through a thin haze layer as seen on the horizon. The bright area near the center top is the glow of Titan's haze illuminated by the sun. A complicated system of drainage channels, some hundreds of meters wide and kilometers long, are seen cut into the hillside. These are probably the result of runoff from methane rain. Stereographic imagery reveals hills to the left to be perhaps a few hundred meters tall, while features in the valley are tens of meters in height. For most of the descent, the probe travels eastward above Titan's surface. However, below 7 kilometers altitude, the motion reverses into a backward westward motion. It reverses again at 1 kilometer altitude, and we move slowly southeastward. Hang on, as Huygens lands on Titan's surface near a water ice outcropping ridge. Another westward-looking view of the descent from 31 kilometers shows the area of Titan over which the probe has just flown. This affords us a good view of the drainage channels and apparent shoreline. More dark lowlands appear and a rough pitted hillside to the left. Spectra of the surface suggest that the bright areas are water ice, and the darker areas are a type of hydrocarbon mixture that has never been produced in the laboratory. The small white dot in the lower center part of scene tracks our progress over Titan's surface. We see the reversal in direction at 7 kilometers altitude, and we fly over the ridge near where we will land. As we approach the surface, our perspective brings the topography to life. We see that although there are rivers and a shoreline, the basin is dry. Below, there are distinct signs of erosion which crafted the rugged ridgeline. Huygens sinks into one of these gullies. We experience a relatively soft landing on Titan's surface. The view from the surface reveals an amazingly Earth-like picture of a dry riverbed with distant hills which are a few meters in height. Some seconds after impact, the shadow of Huygens' parachute drifts across the scene. The heat from the surface science lamp in the probe's skin vaporizes methane from Titan's surface, which is about 180 centigrade degrees below freezing. Near the probe, the ground is littered with water ice rocks and smaller pebbles, which could be made of water ice, or hydrocarbons, or some combination thereof. Although we now know more than ever about this mysterious world,
I'm going to stop it there, but just looking at this picture takes my breath away. This is a picture from the surface of Titan. It's a picture from a place billions of miles away. It's the furthest landing ever successfully pulled off in humanity's history. And it's a place where someday alien life may be discovered. And this is an actual image from the surface of Titan. And it just blows me away to no end that this actually happened. And it didn't really get that much press. So I hope you guys enjoyed that. I can't watch this video without being amazed, even though I've watched it many, many times. Okay, is my screen showing again?
Yes.
Okay. So this shows a picture of Titan, a map of the overall globe. And what's interesting here is if you look at the picture on the right in the inset, you can see a picture of a human footprint. That's an Apollo footprint next to the rocks we saw in the video. So that gives you an idea of how big the features were that we saw in the video. Now, NASA is planning to send a rotorcraft called Dragonfly. It's a drone with 8 rotors to Titan as the next step in the exploration of Titan. NASA is hoping to launch the mission in 2028 to arrive at Titan in 2034. With the mission statement, exploration and discovery on an ocean world to determine how far chemistry has progressed in environments providing key ingredients for life. And included with the mission science, it'll be looking for prebiotic chemistry, for habitable environments, and also actually searching for biosignatures, actually searching for chemical evidence of water or hydrocarbon-based life. And some of the instruments on this probe are pretty cool. It's this one in red. It's a drill, so it's actually going to be drilling into the surface of Titan looking for organics. It also has a mass spectrometer where it will be able to determine what compounds have been drilled from the surface. It's going to have an extensive camera suite. It's even going to have a seismometer, which is not listed here, to look for Titan quakes. And is that it? Yeah, that wraps up what I have on Titan. So I will stop sharing. And are there any questions on Titan before we go on to the next subject?
Couple
One
questions.
question, and
Next.
one question is, what is the size of the dragonfly?
It's about the size of the rovers. Let me see if I think I have a picture of it next to a person, if I can pull up a. Okay, is that screen showing?
Yes.
There's a picture of one of the blades of Dragonfly next to the principal investigator, next to the chief scientist on the mission.
Very good.
Rich, there's a couple questions in text
Oh,
from Gary Valdez. What's Titan's gravity like compared to Earth's or Mars?
yeah, I've got that too. Let me I just have to arrange my. There, can you see that?
Yes.
So we have gravity 1/7 of Earth, surface pressure 1.5 times the surface pressure on Earth, 16 Earth days to a Titan day, and 29 Earth years to a Titan year.
Another question in chat from Zach Walker. Do we still receive telemetry from Huygens or has the mission sunset?
Oh, it's long over. That was in 2005 that it landed.
I believe I remember that it had about an hour and a half worth of battery power available to it when it landed.
Yeah. Okay. Yeah, I'm just amazed that it landed and they got anything out of it. It just it blows me away they got those pictures.
Another question, Rich, how long does it take for radio waves to communicate with Dragonfly? This is from Bill Cheney.
Oh, I think that's in here too. There we go. One-way light time, 70 to 90 minutes.
And
It
a quick
looked in your
follow-up.
pitch.
Oh, go ahead.
My question was what the power supply for Dragonfly will be. It looked like it had the nuclear power.
It does. And I've got, let me see if I can find a slide for that. Am I still sharing?
Yes.
Yes.
Okay. Yeah, so there you go. Remote thermal generator power source. It's essentially a nuclear power source. It's I think it's plutonium-238, but it's not like the dangerous kind. There's multiple safety measures taken with the nuclear power source.
That would make it similar to the rovers on Mars currently.
Yeah. There's many NASA missions that have a nuclear power source.
Rich, a follow-on question from Bill Cheney. How will the Dragonfly determine flight path?
It's autonomous. There's I think there's mission planning that goes into it, but the immediate decisions are autonomous. There's a slide on here somewhere. This kind of explains it. 3 years of science operations, individual flights of several kilometers, and that was explained in here. That it's autonomous to a large extent.
Got it. There's another question from Zach Walker. Has there been any discussion for inclusion of AI in Dragonfly specs?
That I don't know AI specifically. I know, as I mentioned, I know there is some degree of autonomy included with the probe. There has to be because of the delay in getting signals out there. But I couldn't really provide any details or any more information on that.
Thanks, Rich. That's all the questions in chat right now. Is there anybody that wants to mic in with a question before we move on?
Okay, so this again is just a fun true or false question. True or false? There is a world in the solar system with more water than the Earth. And as we know from watching the news and also from Neil's presentation, that's true. And that Jupiter's moon Europa is thought to have twice as much water as the Earth. And that statement never fails to blow my mind. And that when I was a kid, with my brothers and sisters, we used to do this fun game where you spin the globe and you pretend you're an astronaut circling the Earth. And then you put your finger on the globe and you determine, do you splash down and survive or do you land on the land and crash? And you almost always land on water because Earth has, Atlantic Ocean, Pacific Ocean, Arctic Ocean, Indian Ocean. You almost always land in water. And when you think of all the water on the Earth, and you think about this satellite of Jupiter, and that there's twice as much water in the satellite than all the oceans on the Earth, it's hard to get my head around that. And not only that, this is a place where I've actually seen the Galilean moons of Jupiter with binoculars. You don't even need a telescope to see the moons of Jupiter, the four moons. If you prop your elbows up on something and point binoculars at Jupiter, you will see the four moons. And so this is a place you can actually see with binoculars that is very unique and that has all this liquid water. And it's also just very different from the other three large moons of Jupiter, and that the other moons, especially Callisto and Ganymede, are more like our moon in that the surface is very old. You see craters on the surface, whereas Europa, it's got this ice surface with cracks in it, and there's water underneath that ice. It's just very different. It's very different from the other three moons that Galileo discovered. It's very different from pretty much every place else in the solar system. As I mentioned, it's got twice as much water as all the water on the Earth. We know there's a substantial ocean of water underneath the ice. We also believe there's heat sources in this ocean. You get water, you get a heat source. Could there be life there, right? We know that on Earth, extremophiles have been found living near volcanic vents at the bottom of the ocean. Could the same thing happen on Europa? We know that it has the ingredients for life. It has much more water than the Earth. It has the essential elements from formation and impact. It's got chemical energy from above and below, and it's got stability. All this has been simmering for 4 billion years. So at this point, I'm going to share another movie. So I'll stop share. Is that coming through?
Yeah, we can see it.
Okay.
The search for life beyond Earth begins with understanding life on our home planet. And that story, the story of life on Earth, may have begun in our oceans. And that's because, of course, if we've learned anything about life on Earth, it's that where you find the liquid water, you generally find life. So what if I told you that there is an ocean out there beyond Earth, an ocean in our solar system that has been in existence for billions of years? It's an ocean that is perhaps 10 times as deep as Earth's ocean. It's an ocean that is global and may contain 2 to 3 times the volume of all the liquid water on Earth. It's an ocean that exists beneath the icy shell of Jupiter's moon, Europa. So how do we think we know that Europa's ocean exists? Well, it's a combination of using telescopes on the ground and having spacecraft that have flown by Europa and collected data about the surface, about the interior structure, and about the magnetic field around Europa. And the combination of those data sets leads us to a high degree of confidence that this global liquid water H2O ocean is there today, and it's been there for much of the history of the solar system. We used to think that in order for a world to be habitable, you had to be at just the right distance from the sun or whatever your star was, such that you could have a liquid water ocean on the surface. Now, along with liquid water, life as we know it needs two other keystones. The first is the building blocks for life, the stuff you find in rocks. And the second is some form of energy to help power life. And here's where Europa is a real game changer. It is far, far out from the sun, and yet it's got this liquid water ocean. And the reason that Europa has liquid water is because it's orbiting Jupiter, and the tidal tug and pull causes Europa to flex up and down, and all that tidal energy turns into mechanical energy, which turns into friction and heat that helps maintain this liquid water ocean beneath an icy shell. Along with helping maintain liquid water, we think that tidal energy may also allow that ocean to interact with rocks on Europa's seafloor. And it may even give rise to things like hydrothermal vents, which could help provide not just the building blocks for life, but also the energy for life. The question of whether or not life exists beyond Earth, the question of whether or not biology works beyond our home planet, is one of humanity's oldest and yet unanswered questions. And for the first time in the history of humanity, we have the tools and technology and capability to potentially answer this question. And we know where to go to find it. Jupiter's ocean world, Europa.
Okay, so I'll share my presentation again. So basically, in the exploration of a place in the solar system, in general, what NASA does is they start with a flyby. In the case of Jupiter and Jupiter's moons, that was Voyager. Then you do an orbiter around the entire planetary system. In the case of Jupiter, that was Galileo. The next step is the Europa Clipper, which is currently en route to Jupiter, and it will get there in 2030, and the plan is to make 49 close passes over Europa. Now, Neil went into this mission in some depth. What I do want to add to what Neil mentioned is that the long-term goal is actually to land on Europa, and that's a really cool long-term mission because the idea there is actually to get into the ocean. And so first of all, this is a picture of the Europa Clipper. I know we're running somewhat late here. I know Neil already talked about this, so I'm going to skim over this mission to a certain extent. One thing I will add to what Neil mentioned about the mission is that the Hubble Space Telescope has detected geysers on Europa, similar to the geysers from Enceladus. And what that raises the possibility of is the Europa Clipper could actually fly through these geysers and get measurements of what is in the water from the geysers being shot out from Europa, just like water is being shot out of Enceladus. And to me, as an engineer with this strong interest in space exploration in NASA, this would be the holy grail of missions if I could ever have a chance to work on this. It's called the Cryobot Hydrobot mission, and so what it is a probe actually melts through the ice of Europa. So you have one probe melting through the ice of Europa, and that releases a second submarine probe to see what's in the water. And that's a long-term goal, and that would be amazing to see. Basically, the cryobot would melt its way through the ice cover and then deploy a hydrobot, a self-propelled underwater vehicle that would analyze the composition of the water and ice in search for signs of life. And that's where we're headed, I think, long term in the exploration of Europa. Now, to conclude here, more to think about. This to me is a really interesting quote. There was a very famous physicist, and his name was Freeman Dyson. And this is his quote. He says, "Every time a major impact occurs on Europa, a vast quantity of water is splashed from there into the space around Jupiter. Some of the water evaporates and some condenses. Creatures living in the water far enough from the impact have a chance of being splashed intact into space and quickly freeze-dried." So again, this is a very famous, well-known international physicist. He said, quote, "An easy way to look for evidence of life in Europa's ocean would be to look for freeze-dried fish in the in the ring of space debris orbiting Jupiter." That just is an amazing quote. I think this scientist has a reputation for being kind of far out there and saying some pretty kooky things, but he is a well-known and respected physicist. A second quote to think about is Arthur C. Clarke, of course, wrote 2001, A Space Odyssey. Also, not that many people know this, but Arthur Clarke actually predicted the internet in 1968. If you ever read 2001, A Space Odyssey or watch some of the scenes carefully from that movie, you will see people surfing the internet in 1968. And the same guy who predicted the internet, he in the conclusion of his sequel to 2001: A Space Odyssey, he basically had aliens tell the humans, "All these worlds are yours except Europa. Attempt no landing there." And of course, the implication is attempt no landing there because there are creatures there. There are aliens there. Do not disturb them. So to me, all of these places I just described, Titan and Enceladus, Europa, they're just unreal to me. And I'll be excited to see what NASA finds in all three places. And this is far from an official NASA position. This is not NASA's position at all. This is my personal feeling. But my personal feeling and my personal prediction is that before I die, I fully expect NASA to find life, alien life in the solar system, current alien life. Now on Mars, what they're basically focusing on is possible past alien life, a possible life in the past when Mars had water. On Europa, Enceladus, and Titan, which have liquid water, and also organics, there's a possibility for current life. And I will not be surprised at all. And in fact, I personally, again, this is my own personal view, not NASA's view, my personal prediction is that sometime in the near future, there is going to be a discovery from one of these space probes that NASA has discovered life outside of the Earth for the first time. And that's just really exciting to think about. At this point, I'm going to stop sharing and take any questions on Europa or on anything I talked about. Thank you for the opportunity to discuss these topics with you and to share these slides. As I mentioned, this is just really fun for me. I like talking about this stuff. I like hearing about it. I like any new news about this stuff. All of this I find very exciting. And so thank you for the opportunity to share this with you. And yeah, any questions I will attempt to answer now.
One question in chat, Rich from Zach Walker. Do we know the estimated thickness of the ice sheets on Europa?
The thickness of the ice sheets. Let me see. I think I might have that. Hold on. So I can't find the exact thickness of the ice, but here's an overview of the layers. There's the ocean beneath. There's warmer flowing ice between that and the cold, stiff ice at the surface. I can't find a number for how thick the ice is, but I do know just in terms of relative surface thickness to the ocean that Enceladus has the thinnest surface layer. The ocean in Enceladus is relatively close to the surface. The ocean in Europa is further from the surface, and the ocean in Titan is much, much further from the surface. But offhand, I'm sorry, I don't actually have those numbers. Yeah, I'm just having the bar that says the meeting is being recorded is covering where I click to open the chat questions. So
Oh,
this is a matter of being Zoom incompetent on my part.
I'm monitoring it. Actually, there's just a bunch of accolades coming in for you, Rich, because everybody enjoyed the presentation. I can honestly say in the year that I've hosted this year's presentations, this has probably been the most passionate speaker. What a fantastic presentation. Obviously, you love this stuff. It's infectious. Next time you come visit us, you're gonna have to come in person so
Okay.
share your enjoyment and jump up and down at the stuff. And you can play your own music, the appropriate music for the excitement of the slides you're sharing. But this was very enjoyable. Rich, thank you so much. Are there any other questions for Rich? Go ahead and unmute yourself or put it in text, which I'm watching. Any other questions?
Yeah, I guess the other thing I'd like to leave everybody with is, um, again, it just blows me away. You can see these places. Europa with the ice crust, with the subsurface ocean. With one scientist saying, "Look for frozen fish in orbit around Jupiter." You can see the place. You can actually just take binoculars. Don't even need a telescope. Take binoculars, point them at Jupiter, and you'll see Europa. Um,
Yeah, it's crazy technology. I'm going to take a moment to say that when you said cryobot, I glanced up at the slide. I'm a biologist by trade. That is a bacteriophage, same mechanism for you engineers. That's crazy. But that if you're familiar at all with the virus, I don't know if there's any biologists in the audience, but it literally is what a bacteriophage looks like. It's a virus. That it's actually used quite extensively in biotech too. A lot of drug studies and such help propel us with the use of these bacteriophages. Anyway, it looks exactly like the cryobot and the same mechanics too. So I get jazzed by that stuff too. It's very interesting.
Uh, yeah,
Richard,
actually, if I could ask a question to the group, um, this has nothing to do with what I just discussed. But I've been waiting for this nova to go off now for like a year, the T Corona Borealis nova, and I'm just kind of wondering if everybody else has too, because I want to see this thing. I want to see like this is like a once in a lifetime thing, and I keep on watching the news and they're saying, oh, the light curve dipped. It's supposed to like glow, within the next few months, and it just hasn't happened. So I'm wondering if anybody else has been waiting to see this thing too.
Richard, I can probably weigh in on that a little bit. For the last several years, I've been running spectroscopic stuff on T-Corbor. And so there's lots of chat amongst the amateur astronomers as well as the professionals. The real issue is it has a major period of about 80 years. So the last time it actually did go into nova was in 1946. So there's a prediction that in 2026 that that's about the right time that we'd be looking for it. But some of the spectroscopic data that we had prior to 1946 gave us an indication of what would be happening prior to the nova. So we've seen some of the indications in the last 2 years that it's actually acting the same way, increasing and reducing in flux across the band and so forth. So particularly the Balmer series changes drastically compared to the continuum. So we're looking at that moving up and down. And predictions have been made that that's just like what we saw 1 year before the nova in 1946. But stars aren't exactly, obeying, humans' laws when our understanding of
Right.
physics is very, very limited. So there have been some reputable astronomers that have gone out on a limb and made predictions about when it would actually go nova. And unfortunately, that hasn't happened. But we're still seeing lots of fluctuations in T-Corbor, and it will probably, go into an eruption mode, sometime the next year or two, maybe 3 years, who knows? But to go out on a limb and predict when is a difficult thing to do with astrophysics. So it should be fairly bright. The other unfortunate thing is that the media has picked up on this thing and just blown it all out of proportion. They're claiming that we will see this nova in the middle of the daytime for 3 weeks, with naked eye.
Second magnitude.
No,
Second magnitude.
no.
Like,
it's going to go from magnitude, 10 to magnitude maybe 5, 6 or 7. And, that's significant. It puts it close to human ability to see it. And we probably will see it at nighttime if you know where to look, but not in the middle of the day for many weeks. So it's been blown out of proportion. Like lots of things happen when the press picks up on these and goes forward. So anyway, it is a very interesting cataclysmic, recurring variable nova, and so it'll be fun to watch. We have a whole lot of amateurs and a bunch of professionals looking at it photometrically and spectroscopically on pretty much continual basis when it's available. So, we'll have lots of good data. But yeah, it's an interesting one.
I hope it gets up to, I guess the predictions that it will get up to magnitude 2, like Polaris, those are probably too optimistic.
Well, it's who knows. Magnitude 2 is pretty bright, so it's possible. We'll see. But
I'm hoping to see that.
I think it'd be very difficult to see it in the daytime.
Oh, yeah, that I'm not expecting. I'm hoping to see it as bright as a North Star, basically.
Yeah. Well, I think it's worth watching. It's like Betelgeuse. We've discovered that Betelgeuse has a binary companion, and that's part of the reason why it goes through these cycles that we saw in 2019, where it dimmed drastically, and everybody said, "Oh my God, Betelgeuse is dimming. It's gonna go supernova."
It's gonna go supernova, right?
But it was funny because the spectrum never changed. It got dimmer, but the spectrum didn't change. So we're knowing, well, no, it's not supernova. It's something else. And now we have good science data that has pretty much confirmed that it has a small binary companion close to the star. So that's what's causing some of the issues with Betelgeuse. But yeah, all these things, they hit the press and, it goes crazy. So.
Yeah. I think the other thing in the press right now is the 2 comets that are supposed to be passing by. But when you look at the magnitude predictions for those comets, I think they're blowing them both out of proportion, because I don't think either one is going to be nearly as bright as the one, in the picture I got in my background from last year. These both look like they're going to be basically maybe borderline naked eye visibility, and they're getting blown out of proportion, I think.
Yeah, well, everything in space is big news. And it's great because all of us in this room here obviously are interested in what's happening. And it's, also interested in what people think. So,
Yeah.
Yeah, we get these questions in the outreach program a lot, meeting people having questions because they hear things. And, we say, well, I'll show you what we can show you, and here's what we know. So, yeah.
Yeah, the one last year was special. That was special last year. That was pretty cool.
Yeah.
Okay.
Well, thank you for your presentation.
Yeah.
Oh, thank you again. Thanks
Great.
again for letting me share this stuff.
Is a very good look at some things I think many of us haven't realized about these moons, and so it's good to see that. We appreciate it.
Thank you.
Definitely. Yeah. We'll have to have you back, Rich.
I'll be happy to come back, and I've got some
Awesome.
other presentations too.
Awesome. Okay, everybody, that does it for the October meeting. Please do not forget the election coming up. Come help out your club and leadership, and we will see you all in person next month at Gadget Night.
Thank you both.
Thank you.
Thank you.
Coming.